Welcome. Today we're diving into the fascinating world of experimental design. But what exactly does that mean? Experimental design is the structured process researchers use to plan experiments, ensuring that the results are valid, reliable, and meaningful. It's the backbone of scientific inquiry, helping us answer questions and test hypotheses in a systematic way. Whether you're working in a lab, conducting field research, or just curious about how science works, understanding experimental design is essential. Let's start by exploring the core concepts and why they matter in research. Well thought out experimental design is crucial because it determines the quality of your results. Without a solid plan, experiments can lead to misleading conclusions or wasted resources. Good design helps control variables, reduces bias, and increases the likelihood that your findings are accurate. Think of it as the blueprint for your research project. Just like building a house, you need a strong foundation and a clear plan to ensure success. Next, we'll look at the key elements that make up a strong experimental design. Every experimental design shares some core elements: variables, control groups, randomization, and replication. These components work together to create a fair test of your hypothesis. Variables are the factors you manipulate or measure, while control groups provide a baseline for comparison. Randomization helps eliminate bias, and replication ensures your results are reliable. Understanding how these elements interact is the first step toward designing effective experiment. Let's break down each element in more detail, starting with variables. Variables are at the heart of any experiment. There are two main types: independent and dependent variables. The independent variable is what you change or manipulate, while the dependent variable is what you measure as a result. For example, if you're testing how sunlight affects plant growth, the amount of sunlight is the independent variable, and plant growth is the dependent variable. Identifying your variables clearly helps you design a focused and effective experiment. Next, let's talk about the importance of control groups. Control groups are essential for comparison. They don't receive the experimental treatment, allowing you to see what happens under normal conditions. This helps you determine if the changes you observe are truly due to your independent variable or just random chance. For instance, in a drug trial, the control group might receive a placebo, while the experimental group gets the actual medication. By comparing the two, researchers can draw meaningful conclusions about the treatment's effectiveness. Now let's see how randomization fits into the picture. Randomization is a powerful tool in experimental design. By randomly assigning subjects to different groups, you minimize the risk of bias and ensure that differences between groups are due to the treatment, not other factors. This makes your results more trustworthy. Randomization can be as simple as flipping a coin or using computer software to assign participants. It's a key step in making sure your experiment is fair and objective. Next, let's discuss why replication matters. Replication means repeating your experiment to see if you get the same results. This is crucial for building confidence in your findings. If an experiment can't be replicated, its results are questionable. Scientists often repeat studies under different conditions or with new participants to test the robustness of their conclusions. Replication helps weed out errors and ensures that your discoveries are real, not just flukes. Now let's look at the steps involved in designing an experiment from scratch. Every experiment starts with a clear research question. What do you want to find out? The question should be specific, measurable, and focused. For example, instead of asking, "Do plants grow better with more sunlight?" you might ask, "How does increasing sunlight exposure by 2 hours per day affect the height of tomato plants over 4 weeks?" A well-defined question guides the rest of your experimental design and helps you stay on track. Next, let's talk about forming a hypothesis. Once you have your question, it's time to make a hypothesis. A hypothesis is an educated guess about what you think will happen in your experiment. It should be testable and based on existing knowledge or observations. For instance, if tomato plants receive 2 extra hours of sunlight daily, then they will grow taller than those with standard sunlight. This statement sets up a clear prediction that you can test. Next, we'll look at how to identify your variable. Now let's identify your variables. As we discussed earlier, you'll need to determine your independent variable, what you change, dependent variable, what you measure, and any controlled variables, factors you keep constant. For the tomato plant example, the independent variable is sunlight exposure, the dependent variable is plant height, and controlled variables might include soil type and water amount. Clearly outlining these helps you design a fair and focused experiment. Next, let's move on to selecting your groups. Selecting your experimental and control groups is a key step. The experimental group receives the treatment or change while the control group does not. This setup allows you to compare outcomes and see if your independent variable truly makes a difference. For our tomato plant example, one group gets extra sunlight and the other gets the usual amount. Make sure your groups are as similar as possible except for the variable you're testing. Next, let's discuss randomization. Randomly assigning subjects to groups helps eliminate bias and ensures that differences between groups are due to the treatment, not other factors. In our plant experiment, you might randomly assign plants to each group to avoid any hidden patterns. Randomization can be done using simple methods like drawing lots or using computer software. This step is crucial for making your results more reliable. Next, let's talk about how to plan your procedure. Detailed procedure outlines exactly how you'll conduct your experiment. This includes step-by-step instructions, timelines, and materials needed. For example, you'd specify how much sunlight each group receives, how often you'll measure plant height, and how you'll record your data. A clear procedure ensures consistency and makes it easier for others to replicate your work. Next, let's discuss the importance of collecting and recording data accurately. Collecting data is where your experiment comes to life. Carefully measure and record your observations, making sure to stick to your procedure. Accurate data collection is vital for drawing valid conclusions. Use tables, charts, or digital tools to organize your results. The more precise and consistent you are, the more trustworthy your findings will be. Next, we'll look at how to analyze your data. Once you've collected your data, it's time to analyze the results. Look for patterns, differences, or trends between your experimental and control groups. Statistical tools can help you determine if your findings are significant or just due to chance. For example, you might calculate averages or use graphs to visualize the data. Careful analysis helps you draw meaningful conclusions from your experiment. Next, let's talk about interpreting your findings. Interpreting your findings means making sense of the data you've analyzed. Did your results support your hypothesis? Were there any unexpected outcomes? Consider what your results mean in the context of your original question. Sometimes experiments lead to new questions or insights you hadn't considered before. Interpretation is where you connect the dots and understand the bigger picture. Next, let's discuss how to report your results. Reporting your results is an essential part of experimental design. Share your findings clearly and honestly, whether in a lab report, presentation, or publication. Include your methods, data analysis, and conclusions so others can evaluate and replicate your work. Good reporting helps advance scientific knowledge and allows others to build on your research. Next, let's look at some common types of experimental designs. There are several types of experimental designs, each suited to different research questions. The most common are completely randomized designs, randomized block designs, and factorial designs. Each type has its strengths and is chosen based on the nature of the experiment and the variables involved. Understanding these types helps you select the best approach for your research. Let's start by looking at the completely randomized design. A completely randomized design, subjects are randomly assigned to all groups, and each group receives a different treatment. This design is simple and effective when subjects are similar and there are few variables. It's widely used in laboratory experiments where conditions can be tightly controlled. The main advantage is that it minimizes bias and makes statistical analysis straightforward. Next, let's explore randomized block design. Randomized block design is used when subjects can be grouped into blocks based on a characteristic like age or gender. Within each block, subjects are randomly assigned to treatments. This design helps control for variables that might affect the outcome, making your results more accurate. It's especially useful in field studies or when working with diverse populations. Next, let's look at factorial designs. Factorial designs allow researchers to study the effects of two or more independent variables at the same time. For example, you might test both sunlight and fertilizer on plant growth. This design helps you see if variables interact with each other, providing deeper insights. Factorial designs can be complex, but they're powerful for exploring multiple factors in one experiment. Next, let's discuss the importance of sample size. Sample size refers to the number of subjects or units in your experiment. Choosing the right sample size is crucial for reliable results. Too few subjects can lead to weak or inconclusive findings, while too many can waste resources. Statistical tools can help you determine the optimal sample size for your study. A well-chosen sample size increases the power of your experiment and the confidence in your conclusions. Next, let's talk about controlling variables. Controlling variables means keeping all factors except the independent variable constant. This ensures that any changes in the dependent variable are due to your treatment, not other influences. For example, in a plant experiment, you control soil type, water, and temperature. Good control helps isolate the effect of your independent variable and strengthens your conclusions. Next, let's discuss the role of blinding in experiments. Blinding is a technique used to prevent bias in experiments. In a single-blind study, subjects do know which group they're in. In a double-blind study, neither the subjects nor the researchers know. This helps ensure that expectations don't influence the results. Blinding is especially important in medical and psychological research. Next, let's look at the importance of random sampling. Random sampling means selecting subjects from a larger population in a way that gives everyone an equal chance of being chosen. This helps ensure that your sample represents the population and that your results are generalizable. Random sampling reduces selection bias and increases the credibility of your findings. Next, let's discuss the difference between qualitative and quantitative data. Data in experiments can be qualitative or quantitative. Qualitative data describes qualities or characteristics like color or texture. Quantitative data involves numbers and measurements like height or weight. Both types are valuable, but quantitative data is often easier to analyze statistically. Understanding the type of data you're collecting helps you choose the right analysis methods. Next, let's look at common sources of error in experiments. Errors can creep into experiments in many ways, from measurement mistakes to uncontrolled variables. Human error, equipment malfunction, and environmental changes can all affect your results. Being aware of potential errors helps you design better experiments and interpret your findings more accurately. Always double-check your methods and data to minimize mistakes. Next, let's discuss ethical considerations in experimental design. Ethics are a vital part of experimental design. Researchers must ensure the safety, privacy, and well-being of participants. This includes obtaining informed consent, protecting data, and minimizing harm. Ethical guidelines help maintain public trust in science and ensure that research benefits society. Always review ethical standards before starting an experiment. Next, let's look at the importance of peer review. Peer review is the process where other experts evaluate your experiment and findings before they're published. This helps catch errors, improve methods, and ensure the quality of scientific research. Peer review adds credibility to your work and helps maintain high standards in science. It's an important step before sharing your results with the wider community. Next, let's discuss the role of replication in scientific progress. Replication is more than just repeating your own experiment. It's about other researchers independently testing your findings. When results can be replicated, it strengthens scientific knowledge and builds trust in discoveries. Replication is a cornerstone of the scientific method, helping weed out errors and confirm what's true. Next, let's look at how experimental design applies beyond the lab. Experimental design isn't just for scientists in white coats. It's used in business, education, psychology, and even everyday life. Whenever you test a new idea, compare options, or try to solve a problem systematically, you're using the principles of experimental design. This approach helps you make better decisions and understand the world more clearly. Next, let's explore some real-world examples. Medicine, experimental design is used to test new treatments and drugs. Clinical trials follow strict protocols to ensure safety and effectiveness. Patients are randomly assigned to treatment or control groups, and results are carefully measured and analyzed. This process helps doctors and researchers find the best therapies for patients. Next, let's look at an example from education. Education, experimental design helps test new teaching methods or curricula. For example, one group of students might use a new learning app while another uses traditional materials. Researchers compare outcomes to see which method works best. This approach leads to better teaching strategies and improved student outcomes. Next, let's see how businesses use experimental design. Businesses use experimental design to test marketing strategies, product features, or customer experiences. For instance, a company might test two versions of a website to see which one leads to more sales. By analyzing the results, they can make data-driven decisions that boost performance. Experimental design helps businesses innovate and stay competitive. Next, let's discuss the limitations of experimental design. While experimental design is powerful, it has limitations. Not all questions can be answered with experiments, especially when ethical or practical constraints exist. Some variables can't be controlled, and real-world conditions can introduce unexpected factors. It's important to recognize these limits and use other research methods when needed. Next, let's talk about observational studies as an alternative. Observational studies involve watching and recording what happens without manipulating variables. These studies are useful when experiments aren't possible or ethical. While they can't prove cause and effect as strongly as experiments, they still provide valuable insights. Observational studies are common in fields like ecology, psychology, and public health. Next, let's discuss the importance of reviewing literature before designing an experiment. For designing an experiment, it's important to review existing research. This helps you build on what's already known, avoid repeating mistakes, and refine your question. Literature reviews provide context and can inspire new ideas for your experiment. They're a key step in the scientific process. Next, let's look at how technology is changing experimental design. Technology is transforming experimental design. Digital tools make it easier to collect, analyze, and share data. Online experiments can reach larger and more diverse populations. Software can help randomize assignments, calculate sample sizes, and visualize results. Embracing technology makes experiments more efficient and accessible. Next, let's discuss the importance of clear communication in reporting experiments. Clear communication is vital when reporting experiments. Use simple language, organized structure, and visual aids like charts or graphs. This makes your findings accessible to a wider audience, including those outside your field. Good communication helps others understand, replicate, and build on your work. Next, let's look at the role of creativity in experimental design. Creativity is an often overlooked aspect of experimental design. Thinking outside the box can help you develop unique experiments, solve problems, and discover new insights. Don't be afraid to try new approaches or combine methods from different fields. Creativity paired with solid scientific principles leads to innovative research. Next, let's discuss the importance of continuous learning in experimental design. Science is always evolving, and so is experimental design. Stay curious and keep learning about new methods, technologies, and discoveries. Attend workshops, read scientific journals, and connect with other researchers. Continuous learning helps you improve your skills and stay at the forefront of your field. Next, let's summarize the key points we've covered. Let's recap what we've learned about experimental design. We covered the importance of planning, identifying variables, using control groups, randomization, and replication. We discussed different types of designs, ethical considerations, and the role of technology and creativity. Remember, good experimental design is the foundation of reliable research and scientific progress. Next, let's look at some tips for getting started with your own experiment. If you're new to experimental design, start small and simple. Focus on one variable at a time, keep detailed notes, and don't be afraid to ask for help. Practice designing and running experiments to build your confidence. Remember, mistakes are part of the learning process. With each experiment, you'll improve your skills and understanding. Next, let's encourage a mindset of curiosity and discovery. At its core, experimental design is about curiosity and discovery. It's a way to explore questions, test ideas, and uncover new knowledge. Stay curious, keep asking questions, and enjoy the process of discovery. Science is a journey, and experimental design is your roadmap. Finally, let's wrap up with some final thoughts on the value of experimental design. Experimental design is a powerful tool for understanding the world. Whether you're a student, researcher, or just someone who loves learning, mastering the basics of experimental design will serve you well. It helps you think critically, solve problems, and make informed decisions. Keep exploring, keep experimenting, and remember, the best discoveries often start with a simple question and a well-designed experiment.